Hello and welcome to 1.1 Atomic Structure. Let's get you started here. We've got atomic structure we're going to talk about in protons, neutrons, electrons. Those are your subatomic particles. Notice the word subatomic, it means within the atom. There's two things inside the nucleus, that's your protons and neutrons. And there's one type of thing outside the nucleus, and that is your electrons right there, okay? Let's talk about their charge first. If you look at it, protons have a positive 1.6 times 10 to the negative 19th coulombs. That's what these are right here. It's in coulombs. And electrons have a negative 1.6 times 10 to the negative 19th. So they're essentially the same charge but opposites of each other. And neutrons have no charge whatsoever. So if we go over to this box right here, the relative charge, since protons and neutrons are exactly the same charge but opposites, we give them a relative charge of +1 for protons, -1 for electrons, and of course there's your 0 relative charge for your neutrons, okay? Let's go to the mass here. Notice that a neutron and a proton have the same exact mass, okay? And an electron is much, much smaller. So that's almost 10,000 times smaller than, not 10,000, 2,000 times smaller than the protons and neutrons. So when we look at the relative mass of this stuff, since the protons and neutrons have the same mass, we give them a relative mass of 1 AMU, which stands for atomic mass units. And since electrons are so small, we give them a relative mass of 0 AMU. So that's just something to keep in mind, how that works. And hopefully you can memorize that fairly quickly. Let's move on. There's 3 terms you need to know before we move on to the next slide. And that is the element. An element is a group of atoms with the same number of protons, okay? For example, the carbon element has 6 protons in it. Now, there are atoms of carbon that have 6 protons in them and 6 neutrons. There are carbon atoms that have 6 protons and 8 neutrons. It doesn't matter how many neutrons there are, but if they have 6 protons, it is of the element carbon, all right? But you can have many different atoms within that element. They just have to have the same number of protons, all right? Atomic number, the next thing we need to know about, that is the number of protons in an atom. So for example, the atomic number of carbon is 6. It means it has 6 protons. The atomic number of magnesium is 12. It has 12 protons, all right? And then finally, the last term we need to know is what we call the mass number, and that is the sum of the protons and neutrons in an atom. So if we add up all the protons in an atom and all the neutrons in an atom, we call that the mass number. This is not the same thing as atomic mass, which you might have learned in the past. This is something different. It's just add them up, protons plus neutrons, okay? Let's go on. Check this out. So we've got, let's see. We look at these 3 different atoms. These are 3 different atoms, okay? And the black particles inside the nucleus are the proton, and the yellow ones are the neutrons. So we don't even see the electrons in these. These are just the nucleus, or the nuclei of these atoms right here. So if we look here, we got 5 protons in this one and 7 neutrons. So 5 protons, 7 neutrons in the one on the far left gives us a mass number of 12. I didn't write the units, but that would be AMU. Over here on the middle one, we've got 5 protons and 6 neutrons, giving us a mass number of 11. I guess I don't know why I put AMU. There wouldn't be an AMU there. It's just 12. We're not trying to get the weight. We're just getting the mass number. And then finally, over here on the far right, we've got 4 protons, 7 neutrons, also giving us a mass number of 11, okay? So these 2 guys right here, they have the same mass number. But if you look, they have a different number of protons, so they are not of the same atom, or the same element. Number 4 is beryllium, and number 5 is boron. So we consider those different elements. So those atoms are of different elements. But if we look at these 2 here, these guys right here, the left and the middle one, they have the same number of protons in them, but they have different number of neutrons. So these are 2 different atoms. There's no doubt about it. And what we call 2 different atoms of the same element that have different number of neutrons, or different mass numbers, if you will, we call them isotopes. Okay, so they're atoms of the same element with different masses. So they both have 5 protons, so they're both boron, but they're different types of atoms of boron. Hopefully that makes sense. All right? Okay, atomic symbols. We're going to make some atomic symbols here. There's 2 ways to do it. The first way up here at the top is you put the mass number up on the top left right here. You put the atomic number on the bottom left, and here's your element symbol right there. The element symbols will have a capital letter if there's one, and if you have another one like calcium, if you have two letters, the second one is not capitalized, it's lowercase, all right? Let's see. Notice I can tell the number of neutrons in here because this mass number is the protons plus the neutrons. If I have 6 protons and I have 14 protons and neutrons, that would give me 8 neutrons right there, all right? The alternative way of making this chemical symbol is right here. You say the name, carbon, and then you put the mass number to the right after a dash. So carbon 14, these two are the exact same way of writing carbon 14, just one is a little more specific, all right? Let's do a couple of examples here, okay? Write the isotope symbol for an atom that has 26 protons and 28 neutrons. So remember, the element is determined by the atomic number, which is, of course, the number of protons. So if we look up number 26 on your periodic table, you'll find out that that is iron right there. And it has an Fe, capital F, a lowercase e. And then I'm going to throw the 26 down here because that's our atomic number down there at the bottom. And up in the top left, I'm going to write the mass number, which, of course, is the addition of 26 plus 28, which is 54. That's the chemical symbol for iron right there. That's the isotope symbol, if you will. Now, you could have also written this as iron 56, something like that, okay? That's the things we're looking at there. Let's go backwards. Determine the number of all 3 subatomic particles in the atom above. That is bromine 81, I guess you would call that. So let's talk about how that would work. Give me 1 second. I need to look that up. I don't know why I can't remember what the atomic number is of it. There we go. So if we look up bromine on the periodic table, you will see that it has an atomic number of 35. So that means it has 35 protons. Okay, I'm just going to write 35p. Now, these are neutral atoms, and since they're neutral atoms, the protons are positive and the electrons are negative. And if it's neutral, we have to have the same number of protons as we do electrons. So that's how that works. The only one that's a little more difficult is to actually find the neutrons. But remember, this 81 right here is the sum of the protons and neutrons. So if we just subtract them off, you will get a 46. So we have 46 neutrons in that atom right there. Okay? Hopefully you can get those. We'll practice a little bit of those in class and see how it goes. All right, last topic of this section right here is the average atomic mass. What this does is, imagine if I had 2 different atoms of the same element. So I had like a bigger one and a smaller one, and I shot them through this this accelerometer here. There's a thing called inertia, and the heavier ones have more inertia, so they would maybe go this way, and those that have a lighter thing would go down here, okay? And then what we do is we just record how many of the atoms, say we shot in 100 of them, maybe 90 of them hit here and 10 of them hit here, or something like that. But so you can tell how many of them actually hit there. So if we assume that that sample is perfect, then that will tell us what the average is of the number of atoms that are there, or the types of atoms that are there. Imagine like in a tip of a pencil is made of carbon. There are millions and millions of those atoms in there. Some of them are carbon 12, some of them are carbon 13, some of them are carbon 14. So we'll see how that works. All right, so here's how you calculate average atomic mass. It's not too hard. You'll need a calculator for it. And I better get mine real quick. Let's see here, hold on. Getting there, got it. All right, so what you're gonna do, every time you wanna find these atomic masses, is you're going to take the mass of each isotope. Look at this. This is 2 isotopes right. They're the same element, but they're different atoms because they have a different mass. Whoa. And what we do is we got to take this mass, and we're going to multiply it times the fractional abundance, and that'll give us our mass contribution, all right? So the way we get that fractional abundance is just taking the percentage and putting it over 100 or dividing it by 100. I like to just move the decimal point 2 to the left, all right? So if 7.61. So imagine we shot that through that accelerometer, this guy right back here, boom, and it found out that 7.61% of them had a mass of 6.015, and 92.41% of them had a mass of 7.016. That's all it's saying. So boom, it found that out. So I'm going to take this percent here, and I'm going to go ahead and make that into a fractional abundance. See how I moved the decimal point over 2 to the left? And then I'm going to do the same thing with the other one right there. Boom. And now what I'm going to do is I'm going to multiply this one times this one and get my mass contribution, all right? So 6.015 times 0.0761 gives me 0.4577. That'll be good enough for what we need. And then we're going to take the 7.016 and we're going to multiply that times 0.9241. So this guy times this one's going to give us this guy. And that gives us 6.483. 6.483. There we go. And then what we do is we take this one and we just add them together. That's all we're going to do. So 0.4577 plus 6.483 gives me approximately 6.94 right there. That'll be good enough for what we need. That would be what we call the average atomic mass, which is in AMU. And if you look that up on the periodic table, that's going to give you lithium. So lithium on the periodic table has an average atomic mass of 6.94 AMU. Now, some of them are, some of the atoms have only this weight, and some of them have this weight, but if we took 1 million atoms and took the average of them, that would be the average atomic mass, okay? And that's it for today. I hope you enjoyed that lesson.